The double paddle is perhaps the most important part of the Fiddlehead Canoe. It's the power plant that drives the boat forward. It's what you'll be holding in your hands for many hours while you're paddling. So the paddle needs to be efficient in the water, it needs to be comfortable to use, and of course, it should be beautiful too. A well-made paddle is a sculptural thing with ever-changing curves that attracts both the hands and the eyes. Combining all these features may seem like a lot to ask for, but getting it right is not as far out of reach as it might seem. Building the double paddle is a lot of fun. It's easily one of my favorite parts of the entire canoe building project. I'll be using spruce for my double paddles. This is some of the lightest wood we have available where I live. I want the paddle to be as light as possible to minimize strain on the shoulders. Other good options might be cedar or pine. I bought the wood at my local lumber yard. It's cheap construction grade wood. But I did spend some time picking through the piles to find the clearest, straightest pieces. The wood was quite wet when I bought it, so I kept it in my workshop for a while to acclimatize. I used the kitchen scale to see when it stopped losing weight. Some of the pieces bowed quite a bit during this drying process. I'll use these for the short pieces at the blade. The straightest ones I'll use for shafts. Plans suggest gluing each half of the paddle up from 3 pieces. A central 1 1/4 by 1 1/4 inch piece that will be the shaft or loom of the paddle. 2 wider 20-inch long pieces that will give the 6 5/8 total width that's needed for the blade. The wood I have is not very wide, so I'll glue it up with 2 pieces on each side of the shaft instead. Now I want to make the patterns for the blade. One for the face view and one for the edge view. I've laid out a grid as described in the plans, and I've plotted in the widths at the various stations. Now I'm using a flexible batten to draw the convex curve at the edge view. I want it to be a smooth curve that ends at 3/16 or around 5 millimeters. With that line drawn, I'm plotting in the blade thickness at the remaining 3 stations. Then I connect the marks with the batten and draw the second line. Now I want to draw the face view. My lead ducks aren't heavy enough to hold the batten in place for this sharp curve, so I'm using nails instead. Then I cut out the patterns with a pair of scissors. Now I want to cut out the edge profile of the pieces. The paper pattern I made isn't quite stiff enough, so I've transferred the shape to a piece of thin wood that I'll use instead. I'm tracing the edge profile both on the short pieces and on the shaft. I'm drawing the profile on the flat sawn face of the pieces. That'll give me a paddle where the annual rings is vertical to the blade. A vertical grain blade is not necessary, but it's a good idea to consider how the grain of the blade will look before you cut out the edge profile for your pieces. So here I'm at the bandsaw cutting out the shapes. I'm cutting slightly outside the line to give me a bit of leeway in the gluing process. Then I'm gluing up the blades. I'm transferring a reference line from the edge view of each piece to the top of the blade so I can align them correctly. Then I'm spreading the glue. There's a good flat contact surface, so I'm using a polyurethane glue. I'm applying a generous spread to the surfaces. Then I rub the pieces together and I align the reference lines. Checking that there's squeeze out at all the glue lines. And I'm making sure that the pieces are flat against the bench at both ends of the blade. Next day the glue is dry and I'm removing the foamy squeeze out with a scraper. On one side of the blade I don't have the edge profile, so I'm using the pattern to trace it. Then I'm using a spoke shave with a convex sole to plane to the lines. This curve is quite shallow, so a flat sole spoke shave can probably do the job too if you set it to take a heavy cut. I'm making sure to shave from the ends of the blade towards the middle to avoid planing against the grain. When I've reached the lines at the edges, I'm using a ruler to see where I still need to remove material. I try to get it slightly hollow, except at the very tip of the blade. When I'm satisfied with the shape, I use a random orbit sander to smooth and fair the blade. Hand sandpaper will work just as fine, it'll only take a bit longer. Then I flip the blade around and start working on the convex side. Again, I'm aiming for the lines at the edge of the blade. My goal here is to get the center line of the blade to the correct shape. So I'm planing to the pencil lines. And then I'm using the sole of the plane to check if the blade is flat from side to side. When it's flat all the way, I know that my center line has the right curve. Now I'm drawing a center line on the convex side of the paddle. I'm marking the face and I'm also making a tick at the end of the blade. Then I clamp down my straight edge and use it to draw the line. Now I'm ready to trace the face profile of the blade. I'm aligning the lines on the wood with the corresponding lines on the pattern. Then I trace the shape. I'm also squaring the station lines across the blade, but that's not strictly necessary. At the shaft, the blade pattern ends at a width of 7/8 of an inch. I want the shaft to get gradually thicker so that where I'll grip the shaft of the paddle, it'll be at its full 1¼ inch thickness. I'm using a flexible batten to draw a smooth curve. But actually I think a straight line would work just fine too. Then I cut out the blade shape. And I cut off a little bit from the size of the shaft. And I trim off the end of the blade. And I cut to the line at the edge of the blade and at the shaft. When I'm happy with my shape, I'm using a marking gauge to make a line 3/16 up from the concave side of the blade. I'm going all the way around the blade, including the end. Then I begin to shave off wood from the convex side of the blade. I want to go all the way to the line I just marked at the edge of the blade. And I want to go all the way to the center line of the blade. Quite a bit of material needs to be removed near the shaft. It's a hollow cut, so a round sole spoke shave works well for this. At the convex area from the middle to the tip of the blade, I'm using a block plane to cut through the line. Then I'm fairing the shafts. I've clamped them together to get them identical. When they're shaved smooth, I'm flipping around one of the blades to see if it's the same on the other side. If it's not, I shave off a bit more. I'll build a one-piece paddle. So here I'm getting ready to scarf the two parts of the paddle together. If you're building a two-piece paddle that will be joined at the middle with a brass ferrule, you can skip this next step. I'll use a 1:12 scarf to get the best possible strength. So the length of this scarf joint will be around 38 centimeters or 15 inches. total length of my paddle will be 8.5 feet or around 260 centimeters. I feel that this is a good compromise. The paddle won't be too unwieldy while it's still relatively dry. A shorter paddle will be used at a steeper angle, so water from the blade that's up in the air risks getting into the boat. The blades of the paddle are feathered, which means that they are at 90 degrees to each other. I'll build my paddle with right hand control. This means that I'll use my right hand for twisting the blade when I'm paddling. So I've aligned the pieces so that the concave side of the right blade is pointing aft, while the concave side of the left blade is pointing upwards. If your dominant hand is the left one, you will most likely want left hand control. In that case, the left blade should be pointing aft and the right one upwards. I'm cutting close to the scarf line with the bandsaw. Then I'm planing all the way until I've reached the lines and I have a feather edge at the end of the joint. My plane is set to take a fine cut. I'm taking care to get the joint flat and square all the way. Here I'm getting ready to glue up the scarf joint. I want the shaft of the paddle to be as straight as I can get it. The table I'm working at has a flat top and the front edge is straight. So I'm using that as a reference. I'm aligning the shaft with the front edge of the table. I want the glue line where the shaft meets the blade to be right at the edge of the table. And I've clamped a piece of wood to the table that will keep the joint from sliding apart when I add the clamps. With the polyurethane glue I'm using, I want plenty of clamping pressure. I'm using small clamps to ensure that the sideways alignment is good. While the glue dries, I'm building an 8-siding gauge, also known as a spar gauge. The spar gauge is quite a fascinating contraption designed to help you make square sticks into octagons. The clever thing about it is that it automatically adjusts to the varying dimensions of your stick. That's very useful for spars because they are often tapered, or this paddle because the shaft is wider at the middle than it is towards the blades. Here's how it's made. First, I square marks across a stick of wood. These marks should be spaced at a ratio of 7 to 10 to 7 apart. So let's say the first two marks are 7 centimeters apart, then the next two should be 10 centimeters apart, and the last two 7 centimeters apart. This can all be deducted from the Pythagoras theorem, but we won't dive too deep into that right now. In this case, I want a small gauge with a size that's good for a paddle shaft. So my first two marks are 14 millimeters apart. The next two are 20 millimeters apart. And the last two, 14 millimeters apart. This gives the gauge a maximum capacity of 48 millimeters. Here I'm drilling the two pencil holes that are spaced 20 millimeters apart. Then I'm drilling the holes for the nails. These holes are drilled so that the inner edge of the nail will be 14 millimeters from the center of the pencil hole, so just outside the line I've drawn. Then I'm driving in the nails. And I'm putting two short pencils into the holes. So here we have a gauge that can draw a 7 to 10 to 7 ratio. Next day the scarf joint has cured. I'm scraping off the squeeze out and then I'm planing the joint flush. Then I'm ready to use my 8-siding gauge. To get accurate results, I'm taking care to keep both nails touching the shaft of the paddle. Perhaps you can see how the gauge twists a little bit in my hand as the shaft gets narrower towards the blade. It's still a perfect 7:10:7 ratio, although the dimensions of the shaft changes. I'm not sure who dreamt up this little device, but I really think it's quite brilliant. I'm marking all 4 sides of the shaft the same way. Then I have my cut lines. I'm using 2 notched blocks to hold the shaft at 45 degrees while I'm planing. The block plane does most of the work, but near the blades I'm using a spoke shave. Now the shaft is 8-sided. The next thing I want to do is to get it 16-sided. I don't have a gauge for this, so I'm simply doing it by eye. I'm counting how many strokes I need to take with the spoke shave to get facets that are the same width. When the shaft is 16-sided, I'm setting my spoke shave to take a very fine cut, and I try to knock off any high spots that I can see. Now the shaft is more or less round, and I've started working on the perhaps most delicate and artistically challenging part of the entire paddle making process. I'm fairing the blade into the shaft. A lot of these curves are concave, so I'm using my round sole spoke shave for this. I'm trying to get the shapes to blend nicely together, while I still want to get close to the center line and the 3/16 line at the edge of the blade. I think the most elegant way of achieving this is by shaving a hollow where the blade meets the shaft. The hollows at each side of the shaft should meet at a ridge at the center line of the paddle. This ridge should span at least the transition area between the shaft and the blade. And I think it looks good if it continues a bit further down along the center of the blade. The lighting in my workshop is quite flat, so I've rigged up a lamp that will help me see the contours of the paddle better. On the other side of the blade, I want a good transition too. Here I'm shaving a bit off the edge of the blade to make it blend nicely into the round shape of the shaft. When I feel that I'm close to the shape I want, I start sanding. First I sand the shaft. This technique will remove the high spots from the spoke shave. I'm taking care not to sand off the ridge near the blade. Then I'm using my random orbit sander to do the last bit of shaping and pairing. Finishing off with hand paper. I round up the corners and remove any scratch marks that go across the grain of the wood. Now I'm done with the woodworking part of building the paddle. This spruce is astonishingly light. The paddle ends up at only a little over a kilogram, or around 2¼ pounds. The last thing I need to do before the paddle can be varnished is to add the copper tips. These tips will protect the thin end grain at the end of the paddle. First I'm marking the thickness of the blade tip at the middle of the copper strip. Then I'm using my vise to bend to one of these lines. After that, I'm using a scrap of wood that's the same thickness as the blade to finish the bend. Then I give it a final squeeze in the vise. Now I want to add some rivets that will hold the copper tips in place. I'll use 5 rivets at each end of the paddle. I don't have any very thin copper nails, so I'll use bronze ring nails instead. First I'm drilling pilot holes the same size as the nails. Then I'm putting on some thickened epoxy. The purpose of this is not so much to glue the copper as it is to seal the end grain of the paddle. I cut the nails off just slightly above the surface of the copper. After that, I rivet the nails. I'm not using rows. I'm simply peening the ends of the nails to a mushroom shape. Then I'm cutting and filing the copper tip flush. Also rounding off any sharp edges. Of course, I clean off any epoxy smears with alcohol before it dries. Now the paddle is ready for varnishing. Once it's been varnished, I'll add some drip stops. We'll get back to that in one of the next lessons.